For number one, we are determining the validity of equations and inequalities. This is standard 6.10b, and it's pretty straightforward here. We need to plug in 5 here to each of these equations, and the big question here for students is what happens when you have 2 times an x, or do they recognize that it's 2 times that x, right? So 2 times that x equals 10. That's what you have a number next to a variable. That's what that means. So if I were to place that x with that 5, that would mean I've got 2 times 5. And you see right off the bat, we've got our answer. That's 2 times 5 is 10. This is 3 times 5, but it equals 15, not 35, so that doesn't work. This is a 5 minus 3, that equals 2, not 8. This is 5 minus 5, that equals 0, not negative 10. So this one was a pretty simple one for us to get started with. And if we're looking about how we did across the state of Texas, we had 79% of our students get this correct, almost 80%. We're just happy with anything over 60. So the fact that 79% of our students got that correct is fantastic. When we're looking at B and C, each 5%, that's just statistical noise. But there is something about D. So let's take a moment and look at that, because we actually had 11% of our students choose that. They didn't recognize this as multiplication, but what they saw here is 5 minus 5. What they might have been thinking was, for some reason, if this was a negative x, right? If this was a negative x minus 5, then plugging in that 5 would have been negative 5 minus 5. Now it works. So they subtracted that negative 5 from 5 and from the negative 5, and they got to that correct answer, but they supplied that negative that really wasn't there. So overall, this was a pretty easy item. Actually, this is the second easiest item on the test, so it's a great item for the students to get started with, and something that they should feel pretty satisfied about. For number two, we are summarizing categorical data. This is 6.12D, and we've got a tally chart here. Skateboarder recorded the colors of skateboards in use at the skate park. We got blue, green, red, silver. All we need to do is just recognize that word mode. So what is the mode? Now, if we recognize what this means, let's just assume that that's going to be a really simple question. But if we don't recognize what this means, let's see if students can figure this out even without knowing what mode means. So I'm just going to put numbers on top of this, red and blue. Red is 6, blue is 5. Blue and green. Blue is 5, green is 7. Silver and red. Silver is 7, red is 6. And then green and silver, 7 and 7. Even if I don't know what mode means, I can at least say, well, D, at least they both are the same number. And that's not what mode means. Mode does not mean the same number. Mode means the most chosen. So the same number here happens to also be the greatest number chosen, but this is a really simple question, and you can honestly answer this without even knowing what that word mode means. D is our correct answer because the most chosen was 7, and it's split between 2, so you recognize both green and silver as the mode. And this was the number one easiest item on the test, 87%. Honestly, I have not seen a percent correct that high very often in the history of STAAR. That is extremely high. Everything else here is just pure statistical noise. There's no real reason to choose any of the other two, other than the blue and green were the first two colors, red and silver were the last two colors. Um, Red and blue were the two least frequent, but still doesn't really make much of a difference. This was our first easiest. So the first item on the test was the second easiest. The second item on the test was the first easiest, which means it's only going to get more difficult from here. For number three, we are graphing on the coordinate plane. This is 6.11a. Remember, in 6th grade, we are graphing on all 4 quadrants. In 5th grade, we just get introduced to quadrant 1. So we have a triangle, PQR, but I don't see an R. I just see a P and a Q. The base of the triangle is shown. The height of the triangle is 5 units. So which ordered pair could represent point R? Well, let me just plot each of these. Okay, so 4, -2. Well, if I made this, I mean, that would be my triangle, I guess, right there. But that's a weird looking triangle, and that doesn't have a height of 5 units. Okay, so that's not going to work. Let me see, 1, 4. 1, 4. All right, this is at least above Q. So I can make a triangle out of this. That would work. I'm going to use the straight side here as my height. So that's 1, 2, 3, 4, 5. Okay, so this looks like 5 units. And so that looks like that works. Let me check. 6, -1. Okay, 6, -1 is right here. That doesn't make a triangle. That makes a straight line. So that's not going to work. That's not going to work. And then let's check -2, 5. -2, 5. Okay. So this is at least above P. It didn't say which base point it was above. So I could make a triangle from this. But let's check my height. 1, 2, 3, 4, 5, 6. See? We're close, but it doesn't work. So my answer here is B. Now this one was tricky. Our correct answer was B, and we only had 41% of our students get that correct. So this is definitely one we need to work on. And look at D, 30%. Almost as many students chose D as they did B. What was the difference with D? Well, it's the only one that could have made a triangle that worked. A could have made a triangle, but it really wasn't going to be a right triangle. But look what D did. D counted 5 units from the x-axis. So if I just count from the x-axis, 1, 2, 3, 4, 5, it works because its y value is 5. So if you're starting from 0, that works. The problem is we're not starting from 0. We're starting from -1. So that might have tripped our students up. They didn't know where to start counting from. They're just trying to make a triangle. So this is definitely a challenge for students because we're not just graphing a point. We're trying to graph a point and then count the distance. That's a new type of skill that some of these students might not have been exposed to if they've been doing is just graphing random points on the coordinate plane. We also had 22% of our students choose A. I mean, that's greater than statistical noise, and this is one in which it would have worked if you flip these two. Take a look. Let me switch this over to blue. If I were to think that this -2 was my x value, and this 4 was my y value, 1, 2, 3, 4, guess what? Now it works. Let's see how that's the same distance up as this black one over here. So 22% of our students actually had the right idea. They just changed the y and the x value. And then this is just statistical noise, 7%. That's just 5 units to the right of Q, and that just doesn't work. So this was definitely difficult. This was actually tied for our 10th most difficult item on the test. And so when we are graphing on the coordinate plane for students, we need to go beyond just plotting x and y values, but using this as a stem, we can have them create shapes, right? Give them 3 sides of a trapezoid, and they have to plot what the other point can be if it's x units tall, and make it like a right trapezoid. Doesn't have to be what we would consider an isosceles triangle or a triangle that is, standard, right? So what would the other point be? And so they might have to plot something like this, right, to make that right trapezoid. So things like that would just give them additional opportunities, additional at-bats to practice graphing on the coordinate plane. For number 4, we are describing data. This is 6.12b. And we are looking at a dot plot. And it shows the number of games a middle school basketball team won. And it just says the mean of the data and the distribution of the data. Okay, so the mean of the data. Mean is a measure of central tendency, but it's another way of thinking of the average. So what I need to do is I need to add all of these up. So this is 2 plus 4 plus 6 plus 6 plus 7 plus 8 plus 8 plus 9 plus 9 plus 9 plus 10 plus 10 plus 10 plus 11 plus 11. And then divide that by how many schools or how many dots there are, but they already give it to us. There's 15. So let's see, 2 and 4 is going to be 6. I'm going to do 6 and 6 make 12. And I've got a random 7. 8 and 8 make 16. 9, 9, and 9 make 27. 10, 10, and 10 make 30. 11, 11 make 22. So I've got to add all this up. So you see how this is already going to be difficult for students. If they know how to do this, they might not have the energy to go through all of this and add all of these up. So let's add these up. I've got 6 and 2 make 8, and that's going to be 15. Another 6 is 21, 28, 29, right? And then I've got 2, 3, 4, 6, and then another 5 is 11. So I've got 119. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I've got 15 items that I need to have here. And let's just, I don't think that 15 goes into 119. So let's just make sure I added this up correctly. 6 and 2 make 8. That's going to be 13. That's going to be 9. So that's going to be, yeah, I did add that incorrectly. That is going to be 21, and that is going to be 9, that's 30. Okay, so that makes a lot more sense. 120. So that's just a real quick check. If you know you have to divide by 15 and you're looking at something that's 119, I'm pretty sure 119 is prime. That's not going to work. They're not going to make our students do a decimal. So it's always good to go back and double check your work. And I just added that too quickly. So 15 now needs to divide into 120. And that is going to be 8, I believe. Yeah, 120. All right, so 8. So the mean of the data is 8. And then the distribution in our two choices are going to be symmetrical or asymmetrical, right? And this is where it's a 50-50 chance, but students need to know, right? A symmetrical data set is going to be like a mirror. Like you could cut it down the middle like this, and you can fold it over and it looks exactly the same. So sometimes it kind of rises and peaks and comes down like this. It doesn't always have to be like that. Sometimes your symmetrical kind of might start big, dip down, and come back up like that. But something like that is when it's more of like a reflection, and this is definitely not a reflection. This is low, and then it kind of goes up a little bit and comes back down. So that is not symmetrical. So we would need to be able to say this is asymmetrical. So this is a 2-point problem, and this, as you could tell, is definitely um, on the harder side. So to get both points, right, you had to get both of those items correct. We had 30% get that correct. And for 1 point, getting 1 out of the 2, we had 45%. So what we do is we take about half of that, round that up. That's going to be about 23, and add that to our 30. So that gets you about 53% overall correct. So it's definitely not the easiest, but it's actually leaning more on the easier side than the harder side, really towards the middle because it's the 16th easiest. It's tied for the 16th easiest. But on this 6th grade test, we've got 36 items. So it's pretty close to the middle there. We don't know which one they had more of a struggle with and which one they had a little bit easier. Students probably might not have known the difference between symmetrical and asymmetrical unless their teacher really spent some time on that. Those words unless you've really spent some time thinking about symmetry, and finding that root might not be the easiest to define. But on the flip side, you got a 50-50 chance on that. So students might have been able to guess and get that correct. This obviously required quite a bit of work, and even on my initial addition, I had to go back and double check my work. So that could have been a little bit challenging for some of our students, assuming they knew what to do. So when we're looking at this data, we need to look at mean, we need to look at mode, right? We need to look at range, right? Obviously, we could look at IQR, interquartile range. There's all kinds of things we could do. And then we need to look at the shape, right? The symmetrical versus asymmetrical. There's just a lot of things that our students need to be able to do with data in the 6th grade. For number 5, we are solving one variable equations and inequalities, 6.10a. And we have just this basic equation right here, but take a look at the expression on the left, 8x minus 2x. One thing that we need to know is that if you have like terms, right? So I'll give you an example. 8x minus 2, those are not like terms. One is a variable, there's 8x's, and then one is just a constant, 2. You can't do anything with that. But it's not 8x minus 2x. I've got 8x's, so I will draw a picture here. I've got 8x's here, and I want to take away 2x's. So I just took away 2x's. How many x's do I have left? I've got 6x's. So I've got 6x's now equals 48. So 6x's equal 48. So I'm trying to think, well, what could each of those x's be, right? So 6 sets of what make 48? And this is where we need to know our multiplication facts. Because if I have 6 eighths, that makes 48. So we need to know our multiplication facts. But the challenge here is to simplify this left side and to know that 6x's is the same as 8x's minus 2x's. And so our answer here is C. And we did okay. Remember, our threshold for doing okay is anything above 60%. We had 61% of our students get that. We had 18% of our students choose B. And you can tell that they understood this was 6x and 48, but they didn't. You see, they just ended up getting the reciprocal, right? They divided both sides by 48 here. So instead of, they just kind of said, well, I think we need to divide both sides by 48. That would have gotten 1. That would have gotten, um, 1/8 x equals 1. And then that might have confused them, so they just kind of moved the x over there. Like there's a way to get that, but it doesn't make a lot of sense. So if our students get to this point and they struggle, right? You notice I solved mine by just drawing a picture, right? Using a little bit of reasoning. So they might be able to do that. But they kind of got tripped up by B. A also, 14% of our students chose A. So they most likely, when they did the 8x minus 2x, for some reason, they ended up with a negative 6x equals 48. Then they did everything else correct, but when you divide both sides by negative 6 rather than positive 6, you end up with a negative 8. So that might have messed some of them up. And then down to our statistical noise of negative 1/8. So you have to really do a lot of things wrong to get that. So not many students chose that option. Overall, this was fairly easy. In fact, this was the 7th easiest item on the test. So we should be pretty pleased with this result here. For number 6, we are looking at the properties of operations. This is standard 6.7d. And we simply need to find the expression that is not equivalent to 1/2 times 6 minus 2. So that means 3 are going to be equivalent, and one of them is not going to be equivalent. So this is really looking at the distributive property, because when you have this term on the outside 1/2 times, and they don't even need that dot right there. They could just show it like this. Then times an expression within the parentheses. What the distributive property says is we need to take this 1/2 and multiply it by both of the terms inside, right? So 1/2 times x, and then we still keep that minus. 1/2 times 6. Or we could do plus 1/2 times -6. If you really wanted to keep that minus in front of the 6. It's really going to keep the same thing. So either one of these could have worked. So that's how we would distribute that out. So which one is not equivalent? Well, this already A looks good, right? So I can look at A and B look like what I did, 1/2 x. I like that. So let's look at the second terms. -6. Well, I was supposed to multiply that 6 by the 1/2. So if you did this right here, 1/2 x minus 6, they just multiplied the 1/2 by the x and really just ignored that 6. And so I don't think that's going to work. But let's double check the other answers. Okay, so 1/2 times x, we got that on B, minus, okay, so I've got -6 divided by 2. Is that the same as this right here? So I did 1/2 times 6. Is that equal to -6 divided by 2? Well, let's see what this is. -1/2 times, I'm going to make this a fraction, right? And that's going to be a 2. So that does equal -6 divided by 2. All right, so multiplying by 1/2 is the same as dividing by 2. That means that works, so we're not going to use it. Okay, and then these two look slightly different. So here's my question. Is 1/2 times x the same as x over 2? Did that work for them? Well, let's do the same thing. Let's pretend x is a number, right? So if we want to multiply a fraction and a whole number, we make the whole number uh, into a fraction. And so we could just make it x over 1, and that would just be x, right? And so if you multiply straight across, guess what you get? X over 2. So that works. And then -6 over 2, well, what is 6 halves? 6 halves does equal 3. So we're good there. Now, this last one, D, is a little bit tricky. I take my x minus 6, which is what was inside, x minus 6, and instead of multiplying it by 1/2, I just take the whole thing, x minus 6, they just drop the parentheses, and divide it by 2. So the question is, if you multiply it by 1/2, is that the same as dividing by 2? Because when we've got that fraction, having a 2 in the denominator is the same as dividing by 2, because fractions are one way to show division. And we do know that multiplying by 1/2 and dividing by 2 are the same. Because what you can end up doing right here is you can end up distributing this, right? You could end up going x minus 2 minus x over 2 minus 6 over 2, which is one that we already got. It's the same thing as this. So this right here is really the same thing as this one down here. So that means it's good, which means it was that very first one. They didn't do anything with the 6, and that 1/2 has to be distributed out to that 6. So this one, as you could probably tell, was a difficult one. Take a look at our answer selections or answer distribution. 23%, that's below guessing. 24%, 32%, and then 21%. This is as close to just random guessing as I've ever seen. There was one that kind of rose up above, and it was this one, but that one actually was equivalent to 1/2 times x minus 6. It just looks so different. You notice that the 6 is gone. This is the only one in which there's no 6. And then the 1/2 is gone. It's x over 2. So it looks very different, but it's actually the same. So when we're looking at this, and this is our third hardest item, this is difficult for our students. This was just basically random guessing. And so we need to provide lots of opportunities to go through each of these, because what could have been helpful is if you substituted something for x, right? Just make it easy. Let's say x equals 7, right? So we can do x equals 7. So then if we plug that in there, 7 minus 6, that would be 1/2 times, and then 7 minus 6 is 1, so equals 1/2, right? And then just plug 7 in here to all of these places and see, what happens if you get that same value, right? You would end up with simplifying all of these. All of these would simplify to 1/2, but this one wouldn't. This would be 7/2 minus 6, so that's 3/2, so that's going to be like negative, that's going to end up being negative 2/2 or negative 5/12, if you want to look at it like that. So that's the one that wouldn't work. So substitution could also work for this problem. But either way, we need a lot of extra practice on this type of problem for our students because they probably will see something like this going ahead in the future. For number 7, we are looking at area and volume. This is standard 6.8D, and we've got a rectangular prism, and the volume is 192 cubic units, so V equals 192. Let's get that correct. 6.8D. Volume equals 192. And then it's just cubic units. And then the height, we've got this side length down at the bottom. Don't know whether or not it's a square. They didn't say that it's a right rectangular prism. Oh, they do say it's a square base. There we go. So it's a square base, which means those are both 4. And what do we know about volume? We know that volume equals base times height. Okay, so V equals BH. But remember, we learned a different formula when we were first learning about volume in 5th grade. We were looking at length times width times height. Now, they both work. This V equals BH is just a little bit more universal because it works with all kinds of prisms, even cylinders. So the height is the height. This is the tricky part, the base. But you notice what's different between these two? Well, the two h's are the same, which means the difference is this length times width. So the big question is always, what is the base? What is the area of the base? Because that's what this big B means. It's the area of the base. And so the base equals length times width. Okay, so what is length times width? Well, that's 4 times 4, that's 16. So if volume equals 192, so I can say 192 equals my base times height, my base is 16, times my, we don't know, h. Okay, so 16 times what? It's going to give me a 192, right? Or I can just divide 192 by 16, and that would get me h, because multiplication and division are inverse operations. So let's divide 192 by 16. That's going to be, goes in once, and that's going to go in twice. All right, so 12. So 4 times 4 times 12, or 16 times 12, is going to get me 192. And you see our answer right there as B. Now, you might think this is pretty straightforward. And if you think that, you are incorrect, because this is the most difficult question on the test. This was harder than the last one, and students were just guessing. Take a look at A. 65% of our students chose A. If that were the correct answer, we would be very happy with it, 65%. Only 19% of our students chose the correct answer, and then we've got some statistical noise down here. So let's take a look at A. How do you get 48 from this? Well, 48 is pretty easy. If you take your 192 and you divide it by 4, you're going to get 48. So if you know division is required, and you just take the two available numbers, the 192, which is given to us, right? And then the base, which if you think it's a 4, because that's the only number that's given to you, well, what are you going to do with those two numbers? Obviously, I'm not going to multiply those two numbers, because if I multiply those two numbers, I'm going to get something larger. And look at my 4 answer selections. They're smaller. and they're so much smaller, I can't even subtract. 192 minus 4 is 188. So by process of elimination, if I don't know what to do, I'm going to try dividing. And if I divide 192 by 4, I'm going to get 48. Problem is that's not the base. So even though we've introduced and spent a lot of time in 5th grade on what volume is and how to calculate it, some students in 6th grade still struggle, especially as they transition from this first formula to the second formula to realize that the base is the length times the width. And that's why they told us it was a square base. If they didn't tell us it was a square base, then it would have been impossible for us to find because we wouldn't have known what that second side length is for the square. But if it's a square base, that means all 4 sides are equal. So this one was extremely difficult because there was such a convenient answer sitting there that looked like it was just right there, and it was the first answer choice. We need to help our students really deconstruct that volume formula. What is the base? The base is a combination. In this case, the base of a square would be the side times the side. In a rectangle, it would be length times width, but you can have a triangular prism and still you can still use this, right? If you've got a triangle here, and let's say that I could draw a prism right there, you can still use the volume equals base times height. That works for all prisms. Problem is how do you find the area of that base? Well, the area of that base is 1/2 base times height, right? So each shape that is used as a base has its own formula for area. In this case, a triangle is 1/2 base times height. I can draw a trapezoid. That would be different. And when you get into 7th grade, you're going to use circles for cylinders, and that's going to be different. So our students need to know that the base, this big B, is not just a number, it's a mini formula living inside the larger formula. So we're going to look at our next one because this is our most difficult one, so they will get a little bit easier after this. Number 8 is absolute value. 6.2b is our standard. And we've got all of these points plotted on the number line. And we need to find the one that has the greatest absolute value. Well, what is absolute value? Absolute value is distance from 0. So if 0 is your starting point, so I'm going to draw a big line right there. How far are these from 0? These are skip counting by 5. Well, r is pretty easy. The absolute value of r, and we use these two little vertical lines to show that is 0 because it's literally sitting on 0. Let's look at t, right? 5, 10, 15, 20. So the absolute value of t is 20, and it's also 20 units away, so it hasn't changed. It's when we get into negatives, that's when things change. Let's look at q. 5, 10, 15, 20. So the absolute value of q is also 20. Even though q is sitting on negative 20, it's 20 units away. It doesn't matter whether it's left or right. So that means our p is going to be the greatest absolute value. The absolute value of p is going to be 25. So our answer here is A, because that is the farthest away. Now, how do we do on this one? Well, only 41% of our students got that correct, and you can probably guess which one got the rest of it, because look at B and C are statistical noise, 49%. So more students chose T than chose the correct answer of P. Well, why T? Well, T is the greatest positive number. So if you're just looking for what is the greatest number, if we're comparing these numbers from greatest to least, T is it. That's the greatest one. But this comes back to, do we know the definition of absolute value? Do they know that that is the distance from 0, so it doesn't matter whether it's positive or negative, because P is actually a little farther away from 0 than T is. And so obviously that is a supporting standard that we don't see an awful lot, but that vocabulary is very important for our students. This was tied for actually our 10th hardest item. And really, we struggle between, it's a definition issue simply because they're choosing the greatest positive number. And we know that's not a part of absolute value, which means they probably had difficulty accessing the definition or a working definition of absolute value to solve this problem. For number 9, we are looking at triangles. Well, it looks like we're looking at triangles, even though there are no visuals. This is 6.8a. When we start talking about triangles, we should probably be thinking, I need to draw a triangle. So let's draw a triangle, QRT. And I don't know whether it's going to be accurate or not, but I'm just going to draw Q, R, or T. So let's not worry about the side lengths, or let's not worry about the angles. Okay, so angle Q is a measure of 80 degrees. All right, so I'm going to put 80 degrees right there. Angle T is a measure of 35 degrees. All right, so which list shows the lengths, side lengths from order from greatest to least? Well, that's funny. They didn't give me any information on the side lengths. They only gave me information on the angles. They haven't given me this third angle, but I know how to do that. I know a triangle equals 180. So that's going to be 80 plus 35 plus angle R. So 80 and 35 is 115. So if I take 115 from 180, right, that is going to get me 65. Okay, so this is 65 degrees. All right, now, still not going to help me unless I know one thing about triangles. And what I should know about triangles is side lengths are in proportion to the angles they're across from. So the larger the angle, so I'll write this rule for us. The larger the angle, the larger the opposite side length. And we can figure this out just by kind of playing around with triangles. All right, so I'm going to use this connect line feature. I'm going to draw a triangle here, and I want to draw it super thin, like this. Okay, so let's pretend I get that all the way up there. It's close to a triangle. Okay, so take a look at our angles here. We can tell that this is a tiny, tiny angle right here. And these two, try to draw an isosceles. These two are my two largest angles, right? Well, these two largest angles are across from the two longest sides. The tiny, tiny angle is across from the shortest side. Because a tiny angle is going to be across from a short side, a large angle is going to be across from a large side. So you can, without even using any type of ruler or any type of measurement, you can tell the order of the side lengths just by knowing the order of the sizes of the angles. So let's take a look. Q right here is going to be across from RT. So RT is going to be longest. So I need to go from greatest to least. So that's my longest. And so I'm just going to label this side length RT. Okay, greatest to least. I, or T, excuse me, is my shortest. Now, this picture doesn't really pick it up because this isn't a 35-degree angle. But let's just look at our numbers. So that's our shortest. This is QR, which means this 65 degrees is right in the middle. So I'll put middle right here, and that's QT. All right, so here is my list of side lengths in order from greatest to least. So I've got RT, QT, QR. So there's my answer, B. Now, you can't solve this without a picture, and you can't solve this without knowing this truth about triangles. So when we are teaching our students 6.8a about triangles, we've got to go far beyond the fact that triangles have 180 degrees as the sum of the internal angles. That's just basic. We need to go into the side lengths and the triangle inequality theorem. There's a lot of things about triangles we need to know in 6th grade, more than just 180 degrees make up a triangle. So how did we do? We did 23% on A. Our correct answer here of B is a little bit worse, and that's actually 28% was our most chosen answer, or 48%, and that's C. Now, some people probably thought this greatest to least. If you're kind of stuck on this, look how big Q is. Q is 80, and Q is in here, so they thought, well, that's the largest angle. So these two side lengths must be somehow in order, right? But actually, Q as an angle is across from RT. It's across from the one that does not include Q, because if you have a side length that has a Q in it, then it's going to be, one of the two sides that actually make up the angle Q. So you could tell there's a lot of guessing here. Not really sure what's going on with students. This is when we need to go back to the drawing board for our students and just help them understand and play with, kind of like we did down here, how triangles work and deriving some of the theories and the understandings about side lengths and triangles and what constitutes a triangle, what side lengths can and cannot make a triangle. That comes down to concrete manipulatives, playing with straws, playing with strings, and just really getting down to the nuts and bolts of it. So for number 10, we are looking at situational variability. If this looked new to you, that's because this particular standard, 6.13b, had never been tested before. So if it's never been tested and we've been working on these new TEKs since 2016, there's a good chance that a lot of teachers might not have spent a lot of time on this, and textbooks might not spend a lot of time on this. So let's take a look at what it's asking us to do. A school bus was used for a field trip. Which situation about the school bus most likely yields data without variability? All right, so we've got some big words here. Yields data. Not sure why they chose to use this word. We could have just used produces, because this type of yield is more like when something is being produced or something is being grown, like the yield of a crop or the yield of farmland, not the yield sign that students might be familiar with if they're driving around. And then without variability. So we need to know what this means. Variability is the same as change ability. Okay, if I can spell that correctly. And so without changeability means we don't want it to change. So we want data or a situation that is going to produce data that doesn't change. Okay, so the number of seats. So this is the hardest one. We could have gotten by without that word yield. But we needed to know that variability means it changes. So let's just look to see what changes and what doesn't change. The number of seats on the school bus does not change. It stays the same unless they're going to gut the school bus from day to day. The number of seats does not change. Now, the number of students in the bus would change. The speed of the school bus changes all the time as they accelerate and decelerate. The temperature inside the school bus, yeah, it changes throughout the day. Air conditioner, heater, the amount of fuel, yes, it starts full and it declines at a steady rate until it gets refilled. So look, change, change, change. The one that does not change is going to be A. Now, brand new tested standard, not a new standard for us to be teaching, but a new standard that had yet to be tested. We had 53%, so not horrible. We're not necessarily saying that was easy, but uh, it was decent. 12%, 13%, 22%. Now, a lot of students chose this D. Not sure why they would think amount of fuel does not change unless we're not really sure about what that means. If we don't know what variability means, it's kind of hard to figure out what students were using and accessing to try to answer this problem. So this is right in the middle of the test. Technically, it's the 16th easiest or tied for the 16th easiest. But remember, this is a pretty big test, right? And so this is as a 36 item test that's going to be right there, kind of in the middle. For number 11, we are looking at standard 6.5b, wholes, parts, and percents. And we've got a drag and drop here, so this is a 2-point problem. We've got Kara owning 35 books. So of these books, 20% have fewer than 100 and 80% have 100 pages or more. So if I were to draw a strip diagram, I could say that she's got a total, because they give me a total of 35 books, and I've got two parts. So it looks like 20% have 100 or fewer, right? So less than 100, and then 80% have 100 or more, so greater than or equal to 100. Doesn't really matter about these two right here. We're just looking at that 20% and then 80%. So we're supposed to find the correct numbers to fill in the statement. So owns blank books with fewer than 100. So it's 20% fewer than 100, right? And this is 80%. And if we had 100 books, that would be easy because that would just be 20 books and 80 books. But we don't have 100 books. We've got 35 books. So I need to find 20% of 35. Okay, and then I need to find 80% of 35. Or if I find one, and I know that 20 and 80 make 100, I could just subtract that amount from the 35 to get the other. So let's do that. Let's find 20% of 35. There's a few different ways we could do that, right? One way would be to just multiply, change your 20% into a decimal, right? So 0.2, 0.20, and we're going to multiply that by 35, okay? And so I'm going to say that's 10, that's 6, that's 7. No, it's not 70. Got one digit behind the decimal here, so I need one digit behind the decimal. So 20% is going to equal 7. Another way to think about that is what is 10%? 10% of 35, right? That means we're just basically we're dividing by 10. So we're going to take our decimal, we're going to move it in one time. So 10% of 35 equals 3.5. Now, what does that help me? Well, if 10% equals 35, then 20% is simply double that. Double 3.5, you get back to your 7. So there's a few other ways that we could do that as well. We can set up some proportions. Either way, Kara owns 7 books with fewer than 100 pages. I could do the same thing. I could multiply the 35 times 0.8, or I can say, well, if this is 7 and the whole is 35, then I could just do 35 minus 7 to get that missing 80%. And right, that's going to be 28. All right, so we've got 35 total, and that's broken up into a set of 7 and 28. Now that is going to get our 2 points. And so let's see how we did across the state of Texas. So 2 points means you got both of those items correct. We had 40% of our students get both of those correct. 1 point was 11%. So not a whole lot got just one right. That's close to kind of guessing. So really we're looking at about 46%. So we either got it or we didn't. Because look, 0 points, 49% of our students got both of those wrong. So it's kind of hard to stumble into those. And so we just need lots of practice with this. How do you find the percent of a whole, but that whole is not 100, that whole is 35? I showed you two different options here. There are some other ones that students should be flexible with because there are many different ways to do it, and there might be one that's easier for them. Number 12, we are converting units. This is 6.4H, and it's pretty straightforward. We've got 1.5 gallons into cups. All right, so let's see what we have on our reference materials here. We're going to need this. So let's pull this up and let's keep it up. So I've got, there we go, right down there at the bottom. Take a look at what I've got though. I've got 1.5 gallons. So I need to go from gallons all the way down to cups. And you see I have to go through quarts and pints. So this is what I'm going to do. I'm going to draw 1 gallon here, but I'm also going to draw a half gallon right here because that's going to equal, right, my 1.5. So what is 1 gallon? Well, 1 gallon is going to equal 4 quarts. So I'm going to draw these 4 right here, and these are each going to be a quart. So if 1 gallon equals 4 quarts, then half a gallon, right, is going to be half of that. So I've got 6 quarts. So once I can get from 1.5 gallons to 6 quarts, then we're easy. Because then it's just straight whole numbers. But it's that decimal that might mess some students up. Each quart has got 2 pints. Okay, so I've just got some pints right here. And then each pint is going to have 2 cups. Now, rather than drawing all that, what I could do is I can just count how many pints do I have? 2, 4, 6, 8, 10. So I've got 12 pints is going to equal, each pint's got 2 cups, 24 cups. So that is going to be my answer. It's going to be that B, 24 cups. Now, how did we do? That was kind of difficult. That was our 13th hardest on the test. And really, it was that decimal. I think that 1.5 that kind of messed some kids up. You can, right, this 12 obviously kind of messed some kids up because that's the 12 pints, right? So we had 17% of our students choose this. We only had 45% of our students choose the correct answer. And if we're looking at 8 cups, right, we had 17%, we had 21% for 16 cups. These three are so close together, just seems like there's probably a lot of random guessing here. And I'm not sure whether it's just the multiple conversions or whether it was the decimal in that original 1.5 gallons that messed our students up. But either way, we need to give them plenty of opportunities to work with that, in which the starting whole is not a necessarily a whole number, but is a decimal. So we're going to look on number 13. And for number 13, we are looking at ordering rational numbers. This is 6.2D. And so we've got a drag and drop here. Now, this is a lot of movement here, but it's just worth 1 point. So this is a 1 point problem. You either get it completely correct or you get it wrong. There's no partial credit. This is not a 2 point problem. Most drag and drops are. So we need to put this in order from least to greatest. All right, so I'm going to draw a number line here. I see negatives and positives. I'm going to put my 0. All right, so I'm going to at least put my negatives. I'm going to put them in red. So they're coming over here to the left of 0. And I'll put these two positives in blue. They're coming to the right of 0. Okay. Now, without even converting, I can use a little bit of number sense here. Take a look at this. I can make this a -2, and I can cut this right there. Because you see this -1/8 and this -0.209, those are all negative fractions. They're not even a negative whole number. So both of those are going to fall somewhere here. I've got to figure out which one comes first. So this means this is my least number because it's a -1 and something. So I'm going to put this -1 and 7/10 because the two other negatives don't have that whole number. They've got a 0 in the ones place. Now I've got to figure out -1/8. So if I were to change my eighths, right, that's a benchmark fraction I should know. 1/8 is 1.25. So a -1/8 is going to be -0.125. So I'm going to have to put my -0.209 a little bit farther away from my -1/8. It's -1/8, it's -0.125, that's closer to 0. And then look, I don't even need to think too much about these two because this is a proper fraction, which means it is less than 1. So it's going to go somewhere right here. This is an improper fraction. This is greater than 1. And so it's going to go somewhere over here. So I don't even need to convert those. I can just look to see whether they're less than 1 or greater than 1. So that's my order right there. So I've got my -1 and 7/10. And then I had my -209, my -1/8, my 35/52, and then this right here. And then let's make sure that we got everything correct, matched up. And so we do. So this is worth 1 point, and you had to get all 5 correct to get that 1 point. Well, this, as you can tell, was probably one of our more difficult ones. In fact, this is our fourth hardest item. Only 26% of our students were able to get all 4 of those correct. And we had some mixed numbers, some fractions, some decimals. That's definitely difficult for our students, but this is pretty easy to replicate in the classroom without the drag and drop. Um, just make it open-ended. Just give them these 5 numbers, make some positive, some negative, and just let them create their own number line, and then reason out how they could place some between 0 and 1, between 1 and 2, between -1 and 0, so on and so forth. Easy to replicate this for additional practice opportunities for our students. So number 14, we are representing ratios and rates. This is 6.5a. And what we are doing here is we've got a model of a classroom. Uses a scale of 2 inches to 3 feet. Okay, so I'm going to write that down. 2 inches to 3 feet. That's my ratio there of the model. The length of the actual classroom is 30 feet. Okay, so look what I need to do. If I'm going to set up my proportion, I need to make sure I match my units. So in my first fraction, I've got my feet in the denominator. So I need to match that and put my feet in the denominator for the other one. Okay, so what proportion can be used? Well, I could do cross multiplication if I want to, but I also know if I'm making equivalent fractions, 2/3 times something is going to equal my 30, right? 3 times what gets 30? Well, I could just multiply both sides by 10. So I could say 20 feet would get me there, right? Okay, so since that's going to work, let's look at our answer choices. We don't necessarily need to solve it. We do need to set it up. This 20 feet, we can replace with x, okay? And that's actually not 20 feet, that's 20 inches. So let's see which one we have. And we've got our 2/3, right? And our x over 30. Now you notice they flipped them. That's fine. But you notice I've got my 2 across from my x, my 3 across from 30. A is our correct answer. So how did we do? Especially because they kind of flipped the order on us, which is going to be a little bit of a challenge for some of our students. We had 58% of our students get that. So that's pretty good. That's not quite 60, but that's a lot better than the previous problem. They were able to match the units, the feet to feet to inches to inches. 20% chose B, right? And then we've got 16% choosing C, and then only 6% statistical noise choosing D. So really, this is the key, is matching up. I've got inches, I've got feet, and then my other one is feet, so my 2 feet need to be across from each other. You could also set it up like this. You could also say 3 feet is over 30 feet. That's another option, as long as you keep those together. And then you could have done 2 inches is over X. That would also get you the same thing. Your 2 units either need to be on top of each other within the same fraction or across from each other. What we can't have is the feet, one feet being up here and then the other feet being down here. That's what's going to mess us up. So overall, this was the 9th easiest, or tied for the 9th easiest. We did pretty good on that in the state, so good job to our students for that. Number 15, we need to find 2 expressions that are equivalent. As you can see, this is a hotspot, so we just need to select 2 items. This is standard 6.7D. We're looking at the properties of operations. 1 point, because we either find the 2 that match or we don't. And so you notice we're not necessarily simplifying here, okay? What we're doing is we're trying to find 2 that match. So the first unit in each of these, let's just take this right here. 5 times 1.5 or 1/2 p. So take a look at this right here. I've got this 1/2 p times 5. This is good, but now I've got this multiplying by 7, so that doesn't match that one. I've got this distributed out here, 5, and then I've got the 1/2 p minus 2, and that's going to be different because that's going to end up distributing in and making it a 10, so that doesn't match that one. So let's take a look at this one right here. All right, so 5 times 1/2 p, 1/2 p times 5. Okay, so these two match. Okay, so what we have right here, on at least the first expression, is this is just the commutative property. They're just taking the two terms and flipping them. That's the order property. You can multiply in any order. It doesn't matter what order the factors are in, you'll get the same product. So let's check for this one. Let's check the other term. I've got a minus, minus, so that checks. And then I've got the commutative property again. Look at this, 2 times 7, 7 times 2. Same commutative property. So those two are going to be the two that match. You notice that this one doesn't match because it brings that minus 2 in there. So we just have to hit those two. That's going to get us our 1 point. And this is a 1 point problem. Now, how did we do across the state? We had 58% of our students able to match that. So it takes a little bit of looking, right? We just happened to look out with that first one. If that first one didn't match, we would have moved on to the second one. But 58% were able to match it, 42% were not able to match it. But this actually ended up being on the easier side, tied for our ninth easiest because that's really close to that 60%. So that was pretty successful for our students. For number 16, we are representing additive and multiplicative relationships. This is standard 6.6C. And we've got the story problem here about the length of Miss Palmer's camping trailer is X feet. All right, so I'm just going to draw a bar here that's going to represent that, and that's just X feet. And I'll just go ahead and put this up here, Miss Palmer's camping trailer. All right, so if they tell me it's X feet, I'm going to put CT for camping trailer. If they tell me it's X feet, then let's just draw a bar with an X on it. The length of Mr. Guzman's camping trailer, Y, is 6 feet less than the length of Miss Palmer's trailer. Okay, so Mr. Guzman has a camping trailer. It's labeled Y, and it's 6 feet less. So I'm going to draw this like this. Say this is Y. This is Mr. Guzman's camping trailer. And I know that this right here, it's got a difference of 6, right? So that's got a 6 gap right there. All right. So which representation or which equation represents Y? The length of Mr. Guzman's camping trailer. Okay, so Mr. Guzman's camping trailer is in relation to X. Well, we've got this, it's got the full length of X, but then it's got this 6 that I need to get rid of, right? So it's less than 6. So we can just subtract 6 from there. We see our answer right there at D, because it's the full length minus the 6 extra feet that makes up Miss Palmer's camping trailer. Okay, so that is our answer D. Now let's see how we did across the state of Texas. That is the correct answer, D. So we'll start there, 49%. So not horrible, but definitely not at our 60% threshold that we would like. We had 13% choose A, 24% choose B. That's our most chosen incorrect answers. Let's talk about that. So they understand there was a 6. They understood there was a minus. They just didn't know in which order it went. And 6 minus X, that would, to make that would work, what you would need you would need to say Mr. Guzman's trailer is 6 and the difference is X. If it was like that, then you can say 6 minus X. But it doesn't say that. It says Mr. Guzman's trailer is Y. Or yeah, then we would work. We had another 13% on C. And so we knew there was an X, and obviously we've got some type of minus or negative on A, B, and D. But this one was a little bit tricky. It's going to be hard to do without drawing some type of representation. This was our 17th hardest item. So somewhere right in the middle of the test, but slightly on the more difficult side. So this is one in which we need to help our students draw representations to picture the problem. Number 17, we have summarizing categorical data. This is 6.12D. And what we are doing here is we're looking at a project. This project was assigned to 60 students, And each student chose to either create a model, a paper, a presentation, or a video. And then we have a percentage bar graph right here telling us what's going on with that. All right, so what is the number of students who created each type of project? Well, here's the problem. 100% equals how many students? 60 students. That's the trick with these percentage bar graphs. What does 100% equal? There are only 60 students. So whatever I do down here below, and let me go ahead and just scroll that down. I'll just go ahead and clear this off. And I'll start again here. Since I've got that 6.12D is our standard and 60 is the total. So what that means is we need to break this up into sets of 60. Now take a look at this. If this is sets of 60 and it's broken up into 10%, right? What's 10% of 60 or 1/10 of 60? Well, that's going to be 6. So I could just artificially kind of do this. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Well, if I could do that, then that makes this problem pretty easy, right? So the model is the white, and I've got 2 sets of 6. So that's going to be 12. The paper is the very light gray, 1 set of 6, and so that's going to be 6. Now the presentation is the darker gray. That's the big one. So 1, 2, 3, 4, 5. We have 5 groups of 6. And then video's got 2 groups of 6, and that's 12. Now, do all of these added up make 60? Because if 12, 6, 30, and 12 don't make 60, then we messed up. They do make 60. Another way to do this would be to take these percentages here and multiply each of them by 60. So the model is 20%. It goes from 0 to 20. So you would multiply 20% times 60, or that's 0.2 times 60, which is going to equal 12.0 or 12. We would do the same thing. 10% or 0.1 times 60 is going to equal 6.0. And then that's how these numbers are coming up. This 30% for the presentation is 6 times 30 is 180. But since I've got a decimal there, I need the decimal. And then I've got the 12 again. So 12, 6, 30, and 12 is our answer. So 12, 6, 30, and 12. So we're using 12 twice. Now, this is a 2-point problem, so we don't really know if students got some incorrect, which ones they did. But let's see how many we got for 2 points. This was difficult. 27%. Barely 1 out of 4. We're able to get all 4 items correct. Doesn't do much good when you look at the 1% either. So that's overall, take half of that 10%, that's 32%. In order to get both points, you needed 4 correct. In order to get 1 point, you could have gotten 2 or 3 correct. So even if you got half of them correct, you would have got 1 point. 0, 63%. And that's 0 or 1 correct. Now, what makes this so difficult? It's a percent bar graph. And look at some of the numbers that are here. 20. 20 doesn't live in any of our answers, but it lives right there. 10 doesn't live in any of our answers, but it lives right there. This is 30. Doesn't live in any of our answers, but it lives right there. And 20. So my guess is that students that got this wrong are probably plugging in 10, 20, and 30, thinking that the whole is 100. But if I plug in 10, 20, and 30, I'm going to get way more than 60. So step 1 is to understand how a percent bar graph works. We have to know that each of these sections are percentages of a whole, and then secondly, we need to understand what is the whole. Because the whole is not 100, then we're going to need to either break it up into 10% chunks like I did, or multiply by these. So overall, this is very difficult. In fact, this was the 8th hardest item on the test. So this one requires a little bit of extra work for our students and some extra practice. For number 18, we are looking at additive and multiplicative relationships. 6.4a is our standard. And you notice we got a whole lot of words. So it's one that we're not necessarily calculating, we're describing the relationship. So I've got y equals 3x and then y equals x plus 3. And we're literally just trying to describe what's the difference. In y equals 3x and y equals x plus 3, the value of y is 3 more. That's 3 plus. And that's incorrect. It's good for this one, but incorrect on that one. In both of these, the value of y is 3 times, so that's 3 multiplied by x. And it's not good for this one, but it is good for this one. So it's either going to be C or D, but let's see which one explains it correctly. And y equals 3x, the value of y is 3 times the value of x. So that looks good. And then y equals x plus 3, the value of y is 3 more. Yes. Okay, so C looks good. And you see that they flip those in D. So we don't need those. All right, so our answer here is going to be C. And overall, we did decently, as you would expect. 64% of our students got that correct. So decent. We got 12%, 14%, and 9%. So just kind of some random guessing. There wasn't one incorrect answer that really, you know, popped out above the rest. And overall, this was tied for our 5th easiest item on the test. So for the most part, we should be feeling pretty good about this one. So for number 19, we are summarizing numeric data. This is 6.12c. And it doesn't look like a data problem because I don't see any graphs, but if you read the problem, you'll see that we have a data set, and they're just going to give us the numbers here. All right, 5, 1, 2, 3, 9. So you can give us a data set without even giving us a pictograph or a bar graph or a dot plot or anything like that, or stem and leaf plot. So 5, 1, 2, 3, 5, 1, 2, 4, 3, 9. So I'm looking at mean, median, mean, range, range, median, mean, median. Okay, so let's find the mean, the median, and the range. These are the 3 different descriptors that I see listed as my answer choices. All right, so mean and median are both measures of centrality, but they're slightly different. So what is the mean? The mean, another way to think of the mean is the average. So what you do is you take all your items, 5 plus 1 plus 2 plus 4 plus 3 plus 9, and then you divide it by how many items there are. 1, 2, 3, 4, 5, 6. So you take all your data, add it up, and divide it by how many pieces of data there are. So let's see, I've got 5, 6, 10, and then I've got a 15. All right, so I've got 24 over 6. Okay, so my mean equals 4. Now, my median is the middle number. Okay, so 1, I'm going to put them in order. 2, 3, 4, 5, and then look at this 9. This 9, right, is really kind of skewing the data set because I put it out there because it's kind of an outlier. So the middle number is going to fall somewhere in between these two. Now, the mean and the median, sometimes they're numbers that are actually existing within the data set, but oftentimes they're not going to be. So if I take my data set, split it in half, I've got 3 numbers on the left, 3 numbers on the right. So what's in between 3 and 4? Well, you have to supply a missing number. In this case, it's going to be 3.5. So the 9 gets averaged in to my mean and kind of raises up that measure of centrality, whereas the median just kind of treats that as just one different number. It doesn't matter how big it is. So there are different ways to look at centrality. Now my range is the difference between the greatest and the smallest. So I've got 9 minus 1 equals 8. Okay, so I know all of those. Now I'm ready to look. The mean and median are both 4. No. And the range is 8. Yeah, this is very close, but not quite. The mean is 4, but the median is not. The mean and range are both 4. No, the range is not 4. And the median is not 3. Okay, so this one just doesn't work, period. The range is 4. No. The median is 3.5. Yes. The mean is 4. Yes. And the median is 3.5. Yes. Okay, so our answer is D. But that was tricky. We had to get all of that worked out here. And so we only had, take a look at this, 37% get that correct. And it wasn't like there was another answer that really popped out. 23%, 22%, 18%. So there were a few students that worked it out. I'm going to guarantee that some of the students that got it right were guessing. And honestly, that's what I would say a lot of our students did. They looked at this problem and they said, no, thank you, for multiple reasons. One, they didn't know what to do. They got confused between median and motor range. Or secondly, they knew what to do. They looked at all the work that had to be done by hand and they said, nah, I'd rather just guess. So either way, we need extra practice on working through a simple data set like this and calculating the mean, the median, the range. We're not even getting into interquartile range or anything like that. It's just basic mean, median, range, but they have to be able to do it by hand and have the stamina to complete it by hand. This is our 9th hardest item on the test. For number 20, you notice we've got a number line here. We're supposed to select array and move the point on the array to the correct place in the number line. So this is a slightly different problem here. All right, so let's take a look at what we've got. A basketball team is losing by 18 points. Then 3 players each scored an equal number of points and the team won the game. Okay, the opposing team did not score any additional points. So the inequality, here we go. 3p is greater than 18. So the 3 players each scored an equal number of points. They were losing by 18, so it has to be greater than 18. Because if let's say p equals 6, then if each of those 3 players did that, then it wouldn't work because 18 is not greater than 18. 18 ties the game. They don't tie the game, they win the game. So it has to be greater than that, okay? And so one way to look at that is, well, what would equal 18, right? And then just think it has to be greater than that. So we've already figured out that it has to be greater than 6, right? Another way to look at it is think of it like an equation. 3p equals 18. Well, how can we solve for p? Well, if we divide both sides by 3, guess what we get? We get p equals 6. And then basically what we could do is we can just put that inequality back in there. So you can almost treat an inequality like an equation. It gets a little bit tricky when you're dividing or multiplying by negative, but that's something you really get into with in 7th grade. So right now, if they scored greater than 6 points, would they win the game? Well, let's just look at our options here. 7. So if they each scored 7, that would be 21. Yes. If they each scored 8, that would be 24. Yes. They each scored 9, that'd be 27, so that's going to work. So I'm going to put a circle here, and I can put my arrow over here. They have to be greater than 6. Now, I've got 2 options. These 2 down here, open circle or closed circle. Well, the open circle means do not include whatever number we put it on, and the closed circle means include. Well, can I include 6? Well, we already looked at it. If p equals 6, then it's 18, and 18 is not greater than 18. 18 does not win the game, it ties the game. So we're going to need an open circle. And we're going to put it right here on, let's get that out of the way here. This open circle, got to click it. Then you got to put it right there on 6. Okay. So there we go. And if we wanted to remove it, you can remove it. So you have to click on the circle. It's not a drag and drop. Put it right there on 6. Okay, so then that's going to be our answer. If we wanted to include it, then it would need to be like this. Could they tie or win the game? It would need to be 3p is greater than or equal to. If you get that greater than or equal to, then you turn into a closed circle. So this is difficult. This is a 2-point problem, right? This is one, what type of uh, arrow and circle do you need? And then secondly, is it on the right number? So it has to be on the 6. And we had 14% of our students get both points. We had 1% of our students get 32%. Now we don't know, so put that together, you're looking at about 30%. We don't know which one got the 1 point. There might have been a lot of students that didn't know which circle to use, and so they might have used the closed circle at the right spot. Or they might have used the open circle and they just weren't able to place it on the correct spot, or they put it close to 6 but not exactly on 6. So we don't know. We don't have any data as to where they necessarily placed it or which item they got wrong. And we've got a 54%. So this is definitely hard. This is our 6th hardest item on the test. This is an item type that is rarely, if ever, used, especially at the 6th grade. So we need practice. We can help our students practice with just giving them grid paper, problems like this, and them graphing them. First, solving it, right? So turning the 3p greater than 18 into p is greater than 6. But then how do you actually graph that? Open circle, closed circle. Where does that go? They need extra practice on this if they are to be successful on problems like this in the future. For number 21, we are looking at fractions, decimals, and percents. This is standard 6.4G, and it's pretty straightforward. We've got this fraction here, or this decimal here, that we need to turn into a fraction. 0.05 inches of rain. We need to find a measurement that is equivalent to this. Now, I say 0.05, but if we know our place value, 5/100ths, that actually helps us, right? So here's our place value chart, right? And so this is our ones place. This is our tenths place, and so I'll write that as 1/10. This is our hundredths place. So when we have a 5 in the hundredths place, we literally can write 5/100ths like that. So 0.05 is the same as 5/100, right? That's something we learn at the beginning of fourth grade, is that relationship between fractions and decimals. Now I need to simplify this. So I need to think, what number can I divide into both numbers, right? And at this point, it's going to be 5s, because 5 is a prime number, so it's got to be 5. And that's going to be 1/20. So that's going to give us our answer of A. Now let's see how we did across the state. So A was correct. We only had 48 per students. 48% of our students get this correct. So not nearly as high as I would think it would be. We had 12% on B. We had 19% on C, and then we had 21%. So you see what's kind of the same between the C and the D, right? They've got the 1/5, 1/50. So they did something with this 5 that was, uh, they didn't really know how to translate it. So they would just use that 5, and you see the 5 is in the denominator in both of these spots. So this is pretty straightforward, but this is a skill that students need to be able to master in 6th grade, being able to convert between fractions and decimals and percents. And this is our 15th hardest, or tied for our 15th hardest. So one that we think is kind of low-hanging fruit and students should be able to get if they just had some extra practice. For number 22, we are looking at operations with integers. This is 6.3D. And we've got Hassan here. He's gonna using a gift card to buy a pair of jeans for 30 bucks, 2 pairs of socks for $7 each. And then the expression shows the total change in the balance of the gift card in dollars. Okay, so we have a gift card, and then when you buy stuff off a gift card, the balance is being reduced, right, until you use the gift card up. So they take away $30. Hassan takes away $30 for the jeans, and then 2 sets of taking away $7 for the socks. Okay, so we need to just simplify this basically. Well, if I'm taking away two sets of $7, this right here, this is still minus 30. But we can have this two sets of 7 as plus -7 plus -7. So that's really what this is looking at. These two expressions are equivalent. And so let's think, we don't know how much money is on the gift card originally, right? So let's think that if let's just pick a number. Let's just say our gift card is worth $100. Okay, so we're just going to randomly use that, but I want to visualize this for you. We're going to take away 30 bucks. Okay, so we're going to get to $70 because that's the pair of jeans. Then we need two little tiny jumps. Okay, so this is going to get to $63. It's the first minus 7. And then we'll do another tiny jump of 7 minus 7, right? And that's going to get us 56. Now, it doesn't mean there's $56 left. Remember, I made this up. But what's the total change? Well, I took away 30 and 7 and 7. So if you put all this together right here, right, what is that? Well, that's a minus 44. So that's what we're looking for, is what is the total value and change of the gift card? Well, minus 30 minus 7 minus 7 equals this D minus 44, because we took 44 away. And so that's how we would view this. We could also just view this as minus 30 plus minus 14. And we just need to know when we're adding negatives, right, we're going further and further to the left. Okay, so D is our answer. And so this was also tied for our 15th hardest because it also had 48% correct. So just the same as the last item. And we see we've got 25% choosing A. That was our most chosen a correct answer. 14%, 13%. And so what we have here is, this is a simple fix right here. Look at this, 25%. What they did here was they took this 2 minus 7. They simply added that. They added that into a 5. They didn't recognize that this is a multiplication, that you need to multiply the 2 and the -7. So they thought it was just the 2 plus -7, which would make -5, and then you do -30 plus -5, you get your -35. So that's just recognizing multiplication. That has nothing to do with positive or negative integers. And so that's what that is. And this 14% here, -16, this would be if -30 was plus 14. For some reason, they thought that that 2 times -7 ended up as a positive 14. All right, so we're going to move on here to our next item. And for number 23, we are looking at checking accounts. This is personal financial literacy, specifically 6.14a. And you see that the answer is more about describing. There's a little bit of calculating, but we need to be able to describe the effects of the calculation here. So I've got Bank Q and Bank R, and they both have a monthly maintenance fee and an overdraft fee per check. So here's the situation. Customer has a checking account for 5 months and writes 3 checks for amounts greater than the checking amount. Now, we need to know first, what happens when you write 3 checks for an amount greater than the checking account balance? What is that? Well, you get charged what they call an overdraft, but they didn't define that for us. We need to know what overdraft means. So if you've got $20 in your bank and you write a check for $25, you don't have the money when that check gets processed to pay for that. So you get charged a fee. So now you owe more money to the bank. Okay, so we need to check to see which of these banks are going to charge certain amounts based on this. So 5 months. Okay, so what happens if I do 5 months? Well, that's going to be 6 times 5 equals 30. This is going to be 5 times 5 equals 25. So if you're just looking at the monthly maintenance fee, Bank R seems like it's a better deal. Now, they each write 3 checks. So we get a $10 overdraft fee. That's going to be 30. This is going to be a $15 overdraft fee. That's 45. All right. So let's put these together. This is $60 in fees. Okay. This happens to be, oh, look at that, $70 in fees. It's the overdraft. It's really getting you. All right. So now we can compare. The total fees charged by Bank Q, 60, will be $10 less than those charged by Bank R. So 70 or 60 is $10 less than, yeah, that makes perfect sense. That looks good. The total fees charged by Bank Q, 60, is 22 less than Bank R. No, we've already established 60 is 10 less than 70. All right, the total fees charged by Bank Q, 60, is $4 less. So 60 is not $4 less than 70, and then they're not going to be the same. 60 is not the same as 70. Okay, so our answer here is A. Now, how did we do? Well, very close to statistically guessing. We did have 31% of our students get this one correct, which means some students were able to figure it out. But we had 17% getting this. Take a look at this one. We had 45% getting C. So we had more students choose C than we did choose the correct answer. So what is it about C? The total fees charged by Bank Q is $4 less. Okay, well, uh, that could work if you possibly only, calculate for 1 month, possibly, but we need to calculate for 5 months. So that's going to be not necessarily, what we need there because we need to calculate for all 3 months or all 5 months rather than just the 2 months. But honestly, it does look like if we are working with our students, there is quite a bit of math that needs to happen here before they actually just take a look at this. It is a lot of words. It looks like it's more just describing, but we need to be able to calculate first before we use our reasoning to get into the descriptions. So this is our 7th hardest item. This one definitely needs a little bit of work. One key being, what does it mean when you write 3 checks for amounts greater than the checking account balance? Because if you don't know that that's overdraft, then you're already kind of, you know, a little bit behind the 8 ball. 5 months, monthly maintenance fee. Even then, even assuming that some checking accounts have a monthly maintenance fee, there's some personal financial literacy obviously learning here that we need to help our students process so they can successfully um, solve this problem. For number 24, we are classifying number sets. This is 6.2a. 6.2a. And we've just got these digits, or these numbers. Let me put these down here so I can scroll up and down. -3/8, 25, -10, and 0.163. Okay, so what do I know about these digits? Well, let's take a look at here. Well, A is not going to work because I know integers and whole numbers are connected, right? First off, 10 is not a whole number, it's an integer, but really you should have that integers on the outside and then the whole numbers on the inside. So A has just all kinds of problems. At least uh, we've got some options here on B. Let's look. We do have the integers on the outside. We have whole numbers on the inside. Okay, so let's look. Whole number is 25, yes. An integer is a whole number that's either positive or negative. In this case, it happens to be negative, so we're good. So the integer would happen to be that -10 has to be on the outside of the whole numbers because whole numbers are only positive. And then rational numbers are numbers that can show up as ratios. You see that word ratio. So common ones are going to be decimals. Common ones are going to be fractions, sometimes percents, but these are not whole numbers that are either positive or negative, so that sit on the outside. So B looks good. All right, so let's move down to C and D. Let's see what is wrong. If B looks good, what is wrong with that? Well, okay, so you see how this whole numbers is on the outside? That means all whole numbers are integers. That's fine. But it means all integers, or it means that all integers are whole numbers if integers is on the inside, and that is incorrect. Rather than all whole numbers being integers, this shows that all integers are whole numbers. And this negative 10 is not a whole number because it's not positive. So that's not going to work. And this actually shows the correct relationship, right? Whole numbers is on the inside because all whole numbers are integers. But that 3/8, negative 3/8 is in the wrong spot. It is not an integer. It is a rational number. Integers are whole numbers that are either positive or negative. So we do have our correct answer here is going to be B, which is the only one that shows that correctly. Now let's see how we did across the state of Texas. So for A, we had 9%. Okay, so not many people got confused about that. B was 44%. That's our correct answer. And then let's look, we'll say C is 18%, and D is the most chosen incorrect answer, 29%. So D at least had the correct relationship between rational numbers, integers, and whole numbers. The problem was that negative 3/8 need to be put out there. This was difficult, 12th hardest. And it might have been hard because of the scrolling, going back and forth, and really just, we had to obviously know the relationship between integers, whole numbers, and rational numbers. For number 25, we are looking at interpreting numeric data. This is 6.13a, and we've got a stem and leaf plot. So when we're looking at our stem and leaf plot, we've got the ages of people volunteering. Always look at your key. 3/8 equals 38. So that means we're just going to use the most common. This is the tens place. This is the ones place. Right? So this 2 and the 0 equals 20. This 2 and the 8 equals 28. All right. So which of these statements is true? Well, let's just look at the statements. The maximum age of the volunteers is 61. Well, I've got 61 right here, but that's the first number in this row. The maximum age is going to be that 6 and then that 9. That's 69. So that is incorrect. The range of the volunteers is 47. Well, range is the difference between the maximum and the minimum. So the maximum minus the minimum. We already figured out that the maximum is 69 and 20 is our minimum. So that's 49, not 47. Okay, very close. The mode is 65. So mode is the most chosen. So really, we're looking at each of these rows. We're looking for the number that I see 2 2s, the number that shows up the most, 2 1s, 2 8s, and then there we go. I've got 3 5s. So that means that there's 65, 65, 65. That's the only one that shows up 3 times. That does look correct. And there are a total of 20 people volunteering. Ages of volunteers. Well, we need to just count how many items there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 20. Now we're at 25. So that is incorrect. So our answer here is going to be C. And let's see how we did across the state of Texas. We did really well on that, actually. 68% got that correct. So well above that threshold of 60 that we're looking for. We had 8% choose A, 4% choose D, so that's just statistical noise. We had 19% choose B, so let's take a look at that, the range. So they got very, very close. For some reason, they probably just subtracted, that range was that 49, right? They probably subtracted 69, and then they skipped that 20 and just thought 22 was the smallest. So not sure. Not sure why they would do that, but other than that, we did really, really well. Honestly, this was the fourth easiest item on the test. So we typically do pretty good on data interpretation, and the students were able to easily interpret this numeric data. For number 26, we are looking at wholes, parts, and percents. This is standard 6.5b. We've got a problem situation here. We've got a park. 40% of the trees change color in the fall. So you've got 500 trees in the park. How many trees in the park change color? All right, so if we've got, let's say this is our whole thing right here. Let's say the whole thing is 500, right? So what we need is we need about, let's say that's about 40%, slightly less than 50%, right? So the whole thing is 500. Let's draw that to kind of show that the whole thing is 500. And then this is going to be that 40%. Well, how much is that 40%? Well, we've got a few different ways we could do this, right? We could think, well, if we were to take our 500 and break this up into 10 parts, right? We could say that 500 divided into 10 parts, right? You just move the decimal over, you get rid of 0, whatever we want to think about it. Each part is going to be 50. And the reason I say that is because I can look at my 40% and know that that's going to be 4 parts of 10% each. And if each 10% is going to be 50, then that's going to be 50, 50, 50, and 50. So that is going to be 200. Another way to think of it would be, let's just take our 500 and we multiply it by 0.4. The reason I'm doing that is because 40% equals 0.40, and we just need the 0.4. And when we need 40% of something, that means we can multiply it. So 4 times that 500. And as you see here, we're going to get that same answer of 200. Now, it does make sense, right? Half of 500 is 250, and this 200 is slightly less than the 250. This 40% is slightly less than 50%. So either way, our answer here is going to be B, 200. Now, let's see how we did with our answers. That is the correct answer of B, and we had not quite our 60% threshold. We had 54% of our students choose B. The other three didn't really have one that stood out. There were two, both A and C, that had 18%, right? So this 125 is if you multiply that 500 times 1/4. So maybe thinking that 1/4 equals 40%. This 240, right, is you would subtract the 40% from like a 100% to get your 60, and then you multiplied that 60 times that 40, which is not even 240. It's really 2400. So that's a lot of work. I'm not sure what the thinking is behind that. Now, only 10% of our students chose D, that's pretty simple. That's just your 500 minus 40, right? Just the two numbers that you see. They're doing a simple calculation with that. So this is one in which we need to work with students in two parts. Number one, recognizing the problem situation. 40% of 500 means that you can multiply, right, that 40% times 500. And then secondly, the different methods of that. You can change the 40% into 0.4. You can use some reasoning to just break this up into 10 equal parts and then take 4 of those parts, knowing that 40% equals 4/10, or 4 equal parts of that. There's a lot of different options there. So this is kind of middle of the road. Actually lands a tad on our easier side. So this is our 15th easiest problem, but it does have a little bit of area of improvement for our students. For number 27, we are looking at ratios and multiplication. This is 6.4c, and as you can see, it's a multiple select. So we've got to select 2 correct answers. So I've got 5 students for every 2 adults. Okay, so I'm just going to write this right here and make a little T-chart. 5 students for every 2 adults. Okay, so which groups could represent the number of student volunteers and adult volunteers? All right, so could I go to 120 and 48? All right, so let's see, 120. So you see here, this is almost turning into a little bit of a proportion here, right? So 5 to 120, all right, so I'm thinking 5 times what if I were to make equivalent fractions, right? 5 times what makes, if I were to do 5 students, 2 adults, I'm thinking that 120, right? So 5 times 20 is going to make 100, so 5 times 24 is going to get me my 120, which means I would need 2 times 24, that would be 48, and that would work, right? So that's 48 adults. Okay, so this works. So I can mark that one off as correct. I need one more. Let's look at this one, 20 and 50. Well, I don't even need to use multiplication. Take a look at this. You notice how the students are always going to outnumber the adults because there's 5 students for every adults. So I can go ahead and get rid of this because the adults outnumber the students. That's the only one that we can immediately get rid of like that, but we don't need the adults outnumbering the students. All right, 85 and 34. Okay, so if I have 85 students, how many adults do I have? Well, let's set up that same proportion. I've got 5 students, 2 adults, and it needs to equal 85 students. All right, so 5 times what makes 85? All right, so 5 times 10 is going to get me 50, and I need another 35 to get up there, so that's going to be 17. So 17, that's going to be 34. Okay, so that looks like that's going to work. 85 and 34. So it looks like that first and third option. Let's just verify that we've got the other ones incorrect. 70 and 14. All right, so 70, 5 students, 2 adults, 70. All right, so 5 times 10 is going to give me 50. I need an extra 20, so that's going to be times 14. So I need to times 14 here to make an equivalent fraction. And that's going to give me 28. Oh, they just did the times 14. So that's not going to work. Should be at 28 if I want to keep it. And then 65 and 13. So let's do that same thing. 65 students. So 65. Let's go 5 students, 2 adults. 65 students, that's going to be times 13. So times 13, and that's going to be 26. And you notice they just use that, what you multiplied by, that 13. All right, so it is going to be that first and third as our 2 correct answers. Now, this is a 2-point problem, so we had 42% of our students get both correct. We had, for just the 1 point, we had 31%. Okay, so if we take half of that, that's about 16. We're looking at about 58%. So not quite that 60, but also not horrible. We had 27% just get 1. So for this one, it's a lot of multiplication. It's a lot of thinking in proportion. So that's the first step. Do they understand that this is a proportion here? We have this initial ratio, but we could use proportionality to try to test each of these other ones. And so we also could have turned each of these into a fraction and simplified to see if it simplified into 5 over 2. But that's just a different strategy. So students need multiple strategies to kind of attack a problem like this, thinking through various ways what would be the easiest for them to simplify and use proportionality to solve problems like this. This ends up being tied for our 9th easiest, even though it is a multiple select, they're able to think about this proportionally. So that's good, good for our students, show that we're able to have a little bit of success here. For number 28, we are looking at equations and tables. This is 6.6b. And we have a table here showing the relationship between P, number of pairs, F, number of figs. All right, so we need to find an equation that represents this. Well, let's see this. It's getting bigger. All right, so 1, I can either add 1 or I can multiply by 2 to get from 1 to 2. Looking down here quickly, it looks like it's going to be times 2. Now, how do I set that up in an equation? Well, the 1, 3, and 4 are each represented by P. So I can say P times 2 is going to equal my F. And really, at this point, x can be a, a variable, so we wouldn't do that. Since it's a letter and a number, we would just put 2p. 2p equals f. Or if we flipped it, it would be f equal 2p. We can have it on either side. And that is our correct answer. So that's one in which we kind of derived it ourselves. We also could have just solved it by substitution, by just taking each of these and saying, all right, let's just take the 3 and the 6. And so let's just take the 3 and the 6. And if f equals 6, p equals 3. And so we could have said 6 equals 3 plus 1. No. Could have said p is 3. Have to make sure you get in the right spot. 6 minus 4. No. F is 6 equals 2 times 3. Yes. And then p, we could have said 3 equals 2 times 6. No. So you could also use substitution here, and that could have helped us. So our answer is C, and we had 52% of our students get this one correct. So we didn't quite hit our threshold. This is kind of right in the middle of our difficulty level. This is going to end up being the 18th easiest, or tied for the 18th easiest. Now, what's interesting here is we had 10%, we had 12%, so pretty close to statistical noise. Look what happened to D, 25%. So this really tripped us up. Students were able to understand the multiply by 2. They just thought the 2 was multiplied by the F. Now, they probably didn't think that. The thing they probably saw was that P was listed first, F was listed second. So that's the order that D gives it to us. P first, F second. You notice how we had to go from here, we had to flip it to match. And so that's probably what tripped up some of our students, is the directionality, knowing that you can put the F or the P first. It really doesn't matter because they both equal each other. So looking at number 29, we're graphing, and this is literally a graphing problem. This is going to be 6.11a, graphing on the coordinate plane. Our answer is going to be a graph here. And so what we need here is we need to start at -4, -3. So let's get that first. -4, -3 is going to be right there. So let's get that on the graph. So -4, -3. All right, so that's our first point right there. So you just touch the graph where you want it to be. Next, you need to extend the line segment 10 units up. All right, so 10 units up. So let's count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm jumping 10 up. I also just could have said, well, my y value is -3. 10 units up means plus 10. It's going to equal +7. So either way, my second point is still going to be at an x of -4, but now my y is going to be +7, and that is my line segment. And that's it. That's the line segment. You need to touch those 2 points. Okay? You get 1 point for each of these points that we find on the graph. This is a 2-point problem. So for both points, we had 45% of our students. We had 29% of our students get 1 point. So really, if we put those together, half that 29 is 15. We're looking right at that 60%. And then we had 26% get 0 points. So it's interesting to think that some students might be able to get this, but somehow they miscounted the 10 up. That's a lot of units up. They might have gone 9, they might have got 11, they might have somehow moved one of the points over so it wasn't at -4. But overall, this was fairly easy. This was the 8th easiest item on the test. We're at that 60% mark, so for the most part, we're feeling pretty confident with this. For number 30, we are writing one variable equations and inequalities. This is standard 6.9a. and there are 31 people on a bus after 4 people got off. So we need to find an equation for x, the total number of people on the bus before the 4 people got off. Okay, so 31 and 4. All right, so let's figure this out. So look at x right here. X is my total, the total number of people on the bus before the 4 people got off. So I'm going to draw a strip diagram here to represent this. This is a part-whole relationship. So my whole is my total. X, I don't know how many that is. So I know that 4 people got off. So I'm going to just draw a little tiny rectangle here that's going to represent my 4 people that got off. I'll even just kind of draw a little X right there, right? And then there were 31 people on the bus after the 4 people got off. All right, so I think this is going to represent my relationship. All right, so here's my 31 people on the bus after the 4 people got off. So I'm looking for X, the total number of people on the bus before the 4 people got off. Well, how can I find this X? Well, look at my strip diagram. That's going to be pretty easy, right? X is going to equal the 4 and the 31 added together. And so if we were to look at it like that, right, I don't necessarily see that. So what we could do here is we could think, okay, so what are some different ways that we could think about this? Well, I'm not dividing anything, okay? And I'm not multiplying anything. So I'm stuck with kind of these two. Now, what's a different way that we can reimagine this? Well, okay, x equals 4 plus 31. So what does that equal? That means I've got 35. There were 35 people on the bus before the people got off. 4 people got off. Now there's 31. 4 plus 31 makes 35. So which of these, if I were to say my x is 35, is going to make more sense? 35 minus 4 or 35 plus 4 makes 31? Well, if I'm doing a part-whole relationship, right, I could also take my whole, I could subtract one of my parts, and that's going to get me my missing part. So this is going to work. It's going to be that option C, x minus 4 equals 31, because 35 works there. You're not going to add those x and the 34 together because that would make my 31 my total, and that's not my total. So the answer there is C, and we were close to hitting our threshold. We had 58% of our students get this correct, which is pretty good because this was a little bit tricky even with the strip diagram. Without the strip diagram, obviously we're just kind of guessing unless we're able to mentally maybe come up with some other representation. 9%, 13% statistical noise, and as you probably had guessed correctly, take a look at that. 20% got tripped up there. They knew it was an additive or subtractive relationship there. What they didn't know was whether it's a minus 4 or a plus 4. So that thinking through, well, if the answer is 35, using substitution could have worked, or knowing that we've got the strip diagram, you can take the whole, subtract one part, and equal the other part. That would have helped. So this was tied for our ninth easiest. Definitely kind of landed on that easier side of problems for our students. For number 31, we simply need to find the pair of expressions that are equivalent. So we are looking at properties of operations, 6.7d. And the big question is which types of terms can you combine or simplify? All right, so here's our first expression, and we need to see if that simplifies down to 3 plus a. And really it doesn't, because here's the thing. I've got a 5a and then a negative 5, but these are 5a's. So I can't combine 5a's with just a negative 5 because this has got that variable a, and that's got that constant of just negative 5. So what I can combine is the 3 and the negative 5. So this is like 3 minus 5 plus 5a. See how I took this and just kind of rearranged the order of these two right here, right? That's the commutative property. So 3 minus 5 is going to be negative 2 plus 5a, which is not what happens there. But this is just thinking that you can combine the negative 5 and the 5a, which you can't. All right, so that doesn't work. So this 2a is right there. So what you can do is you can multiply, right, you can multiply this 1/5 times the 5. All right, so let's see. 1/5 times the 5 times 5a. So what we can do is we can just make this 5 over 1, so we could just multiply straight across. So this becomes 1 times 5 is 5, 5 times 1 is 5, 5/5 a, which becomes 1a, which we don't really need the 1 is implied, so it just becomes a. So all of this, the 1/5 and the 5 effectively cancel each other out, it just becomes a. So it becomes 2a plus a, because that still needs that 2a, so 2a plus a, that would equal 3a. So this gets a little bit closer on b, but they simplify this 1/5 times 5a to 1, and it should simplify down to a, and then add to that 2a. So it's not going to be this one either. So we can multiply this as well. We can do the negative 1/8 times negative 8 over 1. I'm just going to make that negative 8, and then times the a, right? You can just multiply all three together, just like we did on that last one. So 1 times negative 8, right, is going to equal negative 8. Then I've got the negative 8 times the 1 is going to be negative 8 over a. So really, the two negatives make a positive, so that's just going to be 1 over a, which is just going to equal a. Okay, just plain a. And you see how this one didn't take care of that negative. The two negatives cancel each other out. So this one was very close. So it should be D. Let's see, I've got a whole bunch of A's. Look what I've got here. I've got a 3a, but I've got a plus 8a and a plus negative 8a, which is the same as minusing 8a. Well, if I have an 8a minus an 8a, it just gets rid of itself, and look what you've got left. Just 3a. And both 3a's are correct. Now, this was, as you probably have guessed, a very difficult problem. We only had 29% of our students get that correct. We actually had 27% of our students get A, 29, same amount as correct, get B, and then 14% get C. So for the most part, lots of guessing. There's not much that we can say in regards to students really got tripped up on one, or they really understood one, simply because of how equal the A, B, and D choices were. Very, very tricky. This was our fifth hardest item on the test. So we need to spend time with our students helping them simplify terms. What happens if you add two terms? Can you add the 5a and the negative 5? What happens when you multiply 1/5 times 5a, or negative 1/8 times negative 8a? And simplify that, because that is something that they need some extra practice on, as evidenced by the STAAR problem. For number 32, you see here, we just need to enter in our answer here in this equation editor. We are looking at area and volume, 6.8D. We're going to have to calculate it ourselves. No A, B, C, or D to choose from. So we need to find the volume of the rectangular prism. Now, this is 6th grade. Take a look at our reference material. For volume, we just get this V equals BH. That's the only equation we get. V equals BH, which is the simplest way to do that. But remember, in 5th grade, we learned length times width times height. And these two H's obviously line up. So it's this B turns into my length times width. Well, that's going to be a little bit easier, because look what I've got. I've got a length, I've got a width, and I've got a height. One of them is 1. So anything times 1 is itself. So really, what are we doing here? We're multiplying 5.5 times 3 times 1. Well, 3 times 1 is just going to be 3, so it's 5.5 times 3. So that's 15. It's another 15. Make that 16. 1 digit behind the decimal, 1 digit behind the decimal. So there we have it. We have our answer, 16.5, or 16 and 5/10. So let's get that going here. 16.5. And that's it. That is our answer in cubic meters. Now, it's a 1-point problem. You either get it or you don't. And we had 52% of our students able to get this correct. So not quite at that 60% that we would expect for something as simple as 5.5 times 3, but there's no technology allowed on this. This was middle of the row. This was tied for our 18th easiest item. And this does provide a slight challenge just because, like I said, this base times height, um, you have to calculate the base here. So using the older 5th grade formula, length times width times height, would have been a little bit easier for students. And maybe the times one kind of threw them off because it was so easy they didn't know what to do with it. That could be an opportunity for students to practice if one of the dimensions is 1. For 33, we are looking at real-world ratios and rates. This is 6.4b. And you see we've got a story problem here about on a shelf we have a ratio of science to math books is 4:3. All right, so what I'm going to do is I'm going to quickly just visualize this. So ratio of science to math is science, 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 science. I'll do a different color over here. And then I'll just do math, math, math. So there's my ratio, 4:3. All right, so there are 36 science books on the shelf. Okay, so I need to get this science all the way down to 36. Well, how many sets of 4 do I need? Well, I need 9 sets of 4, because 9 sets of 4, 9 rows of 4 would get me to 36, because 4 times 9 makes 36, which means if that's going to be 9 sets, right, then this needs to be 9 sets. And so what would that be? Well, if I had 9 rows or 9 sets of 4 science books with 3 math books, that would give me 36 science books, and that would give me 27 math books, which is what I'm looking for. So that is going to be our answer of C. Now, how did we do on this? Well, decent. 56% of our students got that. Not quite at 60, but there was just one that really kind of messed us up. That A, 22%. B was a little bit lower, 16%. And we had 6% statistical noise down there at D. So what we did here, right, was on this 48, they multiplied 3 by 12, right? So what they did is they tried to get this 3 to the 36. And they're thinking, okay, well, 3 times 12 equals 36. So therefore, 4 times 12 equals 48, which is correct. The problem is this 3 right here is math books. And so I'm not going to need to figure out from my 3 to my 36 because my 36 is the science book. So that's the trick with these ratios, is lining up the correct units. And that's why I drew my picture there, even with different colors. So my 4 went with my science, my 3 went with my math. You're not going to take your 3 and try to go to your 36 because that would have mixed the two units, and that's the incorrect answer. So this was our 13th easiest item on the test. And the trick here is that both of the 3 numbers given, 4 and 3, are both factors of 36. So you really had to think for a moment as to which number you wanted to multiply, either the 4 or the 3, to try to get up to that 36. And for number 34, which we have here, is going to be multiplying and dividing positive rational numbers. This is 6.3e. And we've got Jada's class here. 3/8 of the students have blue eyes. And what we need to do here is we need to figure out which values are equivalent to this 3/8. So we're really just looking at these benchmark fractions, right? So 3/8 is equivalent to what? Well, we can always divide up if we wanted to. You can turn any fraction into a decimal by dividing up. That means you take your denominator, divide it into the numerator. Now, you're going to have to divide several times before you can get your answer. Decimal, decimal. So it goes into 33 times, 24, 6, another 0. We don't need a remainder. We need to go all the way till we run out, or it starts repeating. 56, There's a 4. There's a 5, and that's going to get us what we need. So it's 0.375. Now you can put these in any order. I can put that there, or if I needed to, I can put that there. And then I need to look for probably I've gotten a fraction and decimal and a percent. Once I've got this decimal, the percent is easy. 1, 2, move the decimal over twice, 37.5%. Now, if you don't want to divide all that, we do know that eighths, if you multiply eighths by any eighths by 125, you're going to get thousandths. Okay? So if we were to multiply 3/8, so that's just something to keep in the back of your mind. If you multiply eighths by 125, you're going to get 1,000. That's going to get 375 thousandths, which is exactly what I got right there, 375,000. So eighths go with 125. So this is a 2-point item here. So we don't know which items students chose, but we can tell you that 2 points, we had 47% of our students get both points. That's pretty good. 16%, though, only got 1 point. So if you add that together, that's an extra 8 points, right? You're looking at about 55% correct. So not quite at that 60% threshold. We've got 37% getting 0 points. And obviously, right, you've got this 3/8, and you got both of these options right here, the 3.8%, the 38%, and then you've got this 0.38. All three of these are wrong, and you know that these confused and probably tripped up some of our students. Overall, this was on the easier side. This was the 14th easiest item on the test, and that's just extra practice on memorizing and working with those benchmark fractions. For number 35, we are multiplying and dividing positive rational numbers. And so we are looking at 6.3e. The previous one was 6.4g, so I apologize for that one. The last one was 6.4g. And so we need to work on this chemistry teacher dividing. And look, they even tell you this dividing 31.5. Okay? 31.5 ounces equally among all the students. If each student got 1.5, so I'm literally dividing 1.5 into 31.5. Now, I don't want a decimal in my divisor, so let's multiply each by 10. 1.5 turns into 15. 31.5 turns into 315. Much easier. So 15 goes into 31 twice. You see how this is just going to line up nice and easy. 21. So it's pretty straightforward if you look at it like that, and if we've got the long division. And this is our 5th easiest, as you probably guessed, because it's literally has the word divide in the word problem, so that we're not guessing as to what what operation we're using here. And we actually had what we were looking for. We had 64%, so we're over that threshold of 60%. 64% choose the correct answer, and we had 10% here. We did get tripped up a little bit by that 30%. Now, that's the scary thing. 17% of our students chose 30. How do you get 30? You get 31.5 minus 1.5. That gets you 30. Let me remind you that the problem did say divide. So 17% of our students just ignore that divide and just divide it to subtract. And that option is obviously going to be there. So for our last item, number 36, we are paying for college, 6.14G. And it is personal financial literacy, so not much calculation, just recognizing contextual clues. So we got Mia's financial aid package from college included funds from the government. After graduation, Mia will start to repay these funds along with interest. Okay, so what types of financial aid do you have to repay? You do not have to repay work study because you get paid for working and that money goes towards your school. You do have to repay a student loan with interest because it's not free money. Savings is money that you've saved, so it's yours. A grant is basically free money. They just give you money. You don't have to pay it back. So this is just recognition Our answer here is B. Now, how did we do across the state? Well, we did fairly well. 71% of our students, great way to end this test, 71% of our students got that correct. The rest is essentially guessing and statistical noise. There wasn't one extra one that kind of got us messed up. This is the third easiest item on our 2024 sixth grade STAAR test.